I'm going to start reviewing lines. This is all the stuff that you should know without any hesitation. So watch it enough so you actually know this material. We have 2 points, x1, y1, x2, y2. We have slope is rise over 1. Run, which is y2 minus y1 over x2 minus x1, which is also delta y over delta x. How else can we define this? What does this mean, y2 minus y1 or delta y? Where is that on the graph? That would be this vertical part here. That's delta y. What about this horizontal? That would be the x2 minus x1 or delta x. Now, what other angle in this triangle, so we have a triangle here and we have a triangle there, what two angles are congruent? That angle and this one, those are both going to be called theta. Why are they congruent? Because you have two parallel lines cut by a transversal. Corresponding angles are congruent. Now what can you say about this big triangle? I have this angle, I have delta y, and I have delta x. So I know that the slope is delta y over delta x, but using also in reference to this angle, we could call that the tangent of theta. This is something that you should know. It's another definition for the slope of a line. The slope of a line equals the tangent of the angle of inclination, which is called theta here. Now that angle of inclination is the angle the line makes with the positive side of the x-axis. So the direction, positive part of the x-axis going to the right. Now let's take a look at these examples here. We have this line. We have theta is in between 0 and 90 degrees. We know that the slope equals the tangent of theta. That's what we just went over. What can we say about this? Well, what can you say about the tangent of any angle between 0 and 90 degrees? It is positive. We know that that line is positive. We can see that slope. Similarly, when we're looking over here, if we're going between 90 and 180 degrees, we're looking at this angle. What can you say about the tangent of any angle between 90 and 180? It is less than 0. If we have theta equals 0 degrees, what's the tangent of 0 degrees? Well, you could look at the y2 minus y1 over x2 minus x1. I just want to go over this because some people have a little difficulty with this. We have 0 divided by some non-zero number, and we get 0. What would the equation of that line be? That would be y equals some number b. And we usually use b because b is used for the y-intercept. Theta equals 90 degrees. The tangent of 90 degrees, we would end up having this time some number over 0, and this is undefined. It has no slope. What is the equation of this line? This one would be x equals a. Here are your general forms for the equations of a line. We have general ax plus by equals c. A, b, and c are integers. This is kind of the fancy notation as you go on in math to say this is double backed z is a set of integers. We have the slope intercept y equals mx plus b. M's the slope, b's the y-intercept. Point slope y minus y1 equals m times x minus x1. M's the slope, and the point x1, y1 is our point. Now, typically if I ask the class, which one of these would you prefer? Overwhelmingly, the people say, oh, I like the slope intercept. What I want to do is I want to break you of that habit. So for now, unless the problem lends itself to using that form, I don't want you to use it. I want you to use the point slope, because once you plug in the point and the slope, you are done. You don't have to do anything else. Alright, let's derive the point slope form using a fixed point x1, y1 and a general point xy. Well, we know the slope m equals y2 minus y1 over x2 minus x1. Now instead of using this x2, y2 point, we're going to use the point xy. So we'll have m equals y minus y1 over x minus x1. And what do we need to do with this? Multiply both sides by x minus x1. And I'll just put it in this, kind of switch the sides. We have y minus y1 equals m times x minus x1. Now these two forms are very familiar, should be very familiar to you, and they're very similar to each other. One thing about the difference between them, they both have a slope and they're both given a point, but the difference is slope-intercept is given a specific point, it's given the y-intercept. Any general point could be the y-intercept, or it could be any other point. Let's use and take a look at how this would look in this problem. We have a point 6 comma negative 2, we have a slope of negative 1/2. Let's use the point slope form. We write y minus negative 2, or y plus 2, equals negative 1/2 times x minus 6. And we're done. We stop. We don't have to do anything else. Use the slope-intercept form. We could either take this equation and then multiply it out, negative 1/2 x plus 3, so we have negative 1/2 x plus 1. Or you could plug in and say negative 2, the y value, equals negative 1/2 times 6 plus b. So we have negative 2 equals negative 3 plus b. b is 1, and we'll get our same equation, y equals negative 1/2 x plus 1. Sorry, that was off a bit. You can see it there. That's pretty straightforward. I don't think you'll have any difficulty with that. But compare this, looking at the work here, to this point slope. We don't have to do anything else. We're done with it. Let's look at the next. Parallel and perpendicular lines. Parallel lines have the same slope, i.e. the slopes are equal, m1 equals m2. Perpendicular lines have negative reciprocal slopes, m1 equals negative 1 over m2, or m1 times m2 equals negative 1. This assumes non-vertical lines. Find the equation of the line parallel and perpendicular to this given line that contains the point 4, 10. So what do we need to do first? If they're parallel, we need to find the slope. So let's take this equation and we'll find the slope of it. Let's move the 3x to the other side. We'll have negative 2y equals negative 3x plus 7. Divide by negative 2, 3/2 x minus 7/2. So if they're parallel, our slope is 3/2 because they're the same. What's our equation? What form are we going to use? We're going to use the point slope form, not the slope intercept. So we just plug it in. Y minus, what's the y value? 10 equals 3/2 times x minus 4. And we're done. The perpendicular slope would be opposite and reciprocal, so we'll change the sign and flip the fraction. So we'll have y minus 10, because again the point's the same, so it's the same y value, negative 2/3 times x minus 4. And that's it. Now what often happens, every year I'll have a student and I tell them you need to do this and do so on the test, and if the form is not specified on a test, you can technically do any form you want. But for this, you plug it in, you're done. You don't have to simplify it, you're done. If you continue or you try to find the y-intercept and you make a mistake, it doesn't matter when you only have 1 point for your answer. If you had it right and then you make a mistake and now you have it wrong. What you need to learn is not to go to that next step in the first place. You stop there and you're done. You have a point, you have a slope, you have the equation. Find the value of x if the line through these 2 points has a slope of negative 2/3. Now, how do we go about doing this? Let's calculate the slope of that. I want to make the x value first on the bottom. So if that's going to be first, then it'll be x minus 8, and then it'll be 3 minus negative 1, or in other words, 3 plus 1. So that's the slope of that segment containing those 2 points, and that's going to be equal to negative 2/3. To solve this, we'll have 4 negative 2/3 times x minus 8. Now there's a bunch of different ways you can go about this. You can multiply it out. I'm going to multiply by the reciprocal of negative 2/3 because that way I'll have just x, 1x here, and then the minus 8, and that'd be easy to get rid of. So if I multiply by negative 3/2, this will be, just to show it, negative 3/2 times 4 equals x minus 8. So then we'll reduce this. 2 goes into 4 2 times. So that'll give us negative 6 equals x minus 8. Add the 8 to the other side, and we get 2. And that is lesson 1.